Everyone, welcome to TechBrain YouTube channel. In this tutorial, we are going to learn how to leverage asynchronous programming with FastAPI to build fast, efficient, and high-responsive APIs. Whether you are just getting started with async or already familiar with the concepts, we will break it down in a clear, straightforward way. By the end, you will have the skills to use async programming to supercharge your API's performance. Let us kick off with some learning objectives to keep our goal clear. Learning objectives. Understand the fundamentals of asynchronous programming. Learn how to set up a FastAPI environment for async development. Use async libraries for HTTP requests, database operations, and file handling. Implement background tasks to enhance API responsiveness. Write and test async endpoints effectively using FastAPI's test client. Apply best practices to avoid common pitfalls in async programming. First, let us understand what asynchronous programming is and why it is a game changer for high-performance APIs. Asynchronous programming is a programming paradigm that allows certain tasks to run concurrently without blocking the flow of the program. When you think about async programming, imagine having the ability to start a task and then move on to the next task without waiting for the first one to finish. This is particularly useful for operations that don't require continuous CPU processing, like IO-bound tasks. Examples of IO-bound tasks are HTTP requests, database queries, file system operations. These operations spend a lot of time waiting around. For example, waiting for data from a server or reading from a disk. And async programming lets your code do other things during the wait time. Let's compare the two to see why async is so awesome. One task runs at a time. Task A starts, finishes, then task B starts. If task A is waiting on something, like a network response, task B has to wait too. This can be very inefficient when dealing with high latency operations. Async programming, on the other hand, task can overlap. While task A is waiting for something, task B can run. Improve scalability and resource usage by keeping the CPU busy with tasks that don't require waiting. It allows high concurrency, meaning more things can happen at once without slowing down your app. So now that we understand async programming, why should we use FastAPI for our next async project? FastAPI combines the performance power of Starlet, a lightning-fast ASGI framework, and the data validation capabilities of Pydantic, the ability to build APIs that are not only fast but also maintainable and easy to scale. FastAPI natively supports async or await syntax. This means you can write asynchronous code with ease and without any special configuration. You can use async defined for your endpoint and await for making async calls like HTTP requests or database queries. FastAPI is designed for high concurrency with minimal latency. It can handle thousands of simultaneous connections efficiently, which is exactly what you need when building real-time or high-traffic APIs. So, if you're looking to make your API supercharged, scalable, and responsive, FastAPI is definitely the way to go. Set up a few FastAPI endpoints to make our API snappy and efficient by incorporating asynchronous programming. This tutorial will show you how to create async endpoints for IO-bound tasks like making HTTP requests, reading files, and even running background tasks. Let us walk through some real code examples that use async await, async libraries, and background tasks to boost your API's performance. Thing to do is to create a directory. So we're going to name the directory test first API. So now let's cd into the directory. Is to create a virtual environment. Let us create a virtual environment in the directory. We created a virtual environment. Let us activate our virtual environment. Now we've activated our virtual environment. The next thing to do is to install the required libraries for this project. Create a file in our directory and name the file app.py. Now let's open our Visual Studio Code. You can see we successfully create our file. Now let's start coding. First, we imported the necessary modules and initializing our FastAPI app. Here we import FastAPI to create our web API. Background tasks to handle background jobs like sending emails or processing tasks without blocking the main response. Then we import HTTPX to make asynchronous HTTP request. We will use this for calling an external API. We import the AIO files for async file operations. We will use this to read files asynchronously. We also imported PyTest for writing and running async test. Then we import the test client from FastAPI for use for testing our FastAPI app without needing a live server. Now let us go through each endpoint we are going to implement step by step. We are going to create a simple endpoint that takes an item ID and returns it in the response. Why this endpoint doesn't have any IO operations, we will still define it asynchronously to show how to structure async endpoints. Here, the endpoint is defined as async defined, making it non-blocking. We are using path parameters item ID to fetch a specific item ID and returning it in a dictionary. Next, let us create an endpoint that calls an external API asynchronously. We will use HTTPX async client function to make a non-blocking HTTP request. In this endpoint, we use HTTPX async client function to make the API call asynchronously. The await keyword allows us to wait for the response without blocking the rest of the program. Once the response is received, we return the result as JSON. This is a typical use case for async programming, waiting for external services without blocking your server. Let's now create an endpoint to read a file asynchronously. Instead of blocking the main thread while reading a file, we can use AIO files, which allows non-blocking file operations. Here, we use AIO files open function to open the file asynchronously. The await keyword ensures the program doesn't block while reading the file, allowing other requests to be processed concurrently. The file content is returned as JSON. See how to handle background tasks. We will create an endpoint that schedules an email to be sent in the background while responding immediately to the client. In this example, the send email function simulates sending an email. We used background tags add tags function to run send mail in the background without blocking the main response cycle. The client receives an immediate response saying email scheduled, but the actual email sending happens in the background. Background tags are perfect for things like sending emails, logging, or other long-run operations that don't need to block the main response. Let us write some tests for these endpoints to make sure everything works as expected. We will use FastAPI's built-in test clients for testing our async endpoint without the need to run a live server. Simple test for the read item endpoint to ensure it returns the correct item ID. We call the client get method to make a get request to item endpoint. Then we assert that the response status code is 200 and the JSON response matches the expected output. Next, let us test the read file endpoint. First, we need to create a test file with some content. We create a file named example.txt with content. Then we make a GET request to read file and verify that the content is read correctly and returned in the response. Now let us test the schedule email endpoint, which adds an email task to the background. We check if the response is correct. We call the endpoint using client post method, passing the email as a query parameter. We check that the response contains the expected message, confirming that the email was successfully scheduled in the background. Finally, let us write an async test for calling the external API. Here, we use HTTPS async client method to make an asynchronous request directly within our test. We use HTTPS async client method to make an async GET request to the external API. We check that the response status code is 200 and that the returned JSON contains the ID key. Now to run this test, simply execute the following command in your terminal. This runs all the text in our code, making sure everything works as expected. Then we'll see that the test passed, confirming that our async endpoints are functioning correctly. Now you've built a FastAPI app with asynchronous programming for making HTTP requests, reading files, and handling background tasks. You've also written tests to ensure everything works smoothly. Async programming makes your app non-blocking, allowing it to handle many tasks concurrently. Background tasks allow you to offload time-consuming operations, like sending emails without affecting the user experience. With FastAPI and async programming, you can build APIs that are fast, scalable, and efficient. Keep us wrap this up with some killer best practices and tips to make sure your asynchronous FastAPI app is as fast and reliable as possible. If you're writing async code, you need to be aware of the right strategies to maximize performance. Keep things scalable and ensure that everything works seamlessly. Into some pro-level practices that will make you an async ninja in no time. Number one here is avoid blocking code. Replace async libraries with async alternatives. One of the most important things to remember when writing async code is to avoid blocking operations. That is the whole point of using async. We want to let other tasks run while we are waiting for something like a database query or an HTTP request. But here is the catch. Synchronous code, for example, timesleep or sync database libraries, it can block the whole events loop, making the entire program slower. Here's the tip. Always replace sync libraries with their async equivalent. For example, use HTTPX instead of requests of HTTP calls. Use HTTPX instead of requests for HTTP calls. Use async PG instead of psycobj2 for PostgreSQL database query. Use async PG instead of psycobj2 for PostgreSQL database queries. Use AIO files instead of the standard file IO libraries open. Use AIO files instead of the standard file IO libraries like open method. Switching to these async libraries ensures that your app doesn't get stuck waiting on slow operations. Your events loop will keep running, handling other requests while waiting for IO bound tasks. Number 2, monitor performance. Use tools like Prometheus or Relic or New Relic. Asynchronous programming can really boost the performance of your app, but with great power comes great responsibilities. Monitoring your app's performance is essential to make sure it is scaling well and not running into bottlenecks. Two excellent tools for this are Prometheus, which collects real-time metrics and can be paired with Grafana for visualizing data. We also have New Relic. This provides real-time insights into your application's performance, helping you to detect slow endpoints or database queries that could be causing lag. By monitoring performance, you can identify when certain async operations are not performing as expected and make adjustments accordingly. For instance, if you see that a particular async function is making longer than expected, for instance, if you see that a particular async function is taking longer than expected, maybe the API you're calling is slow, or, or perhaps the database connection could be optimized. Number three, the third point here is test thoroughly. Simulate load to identify bottlenecks in async execution. Testing is always critical, but it is even more important when working with asynchronous code. It is easy to assume that async functions are performing as expected, but you need to simulate load to make sure your app holds up under real-world usage. Here's the deal. Unit tests will check individuals' async functions and endpoints to ensure that they behave correctly. Load tests using tools like Locust or Artillery simulates multiple requests hitting your API concurrently so you can see how well your app handles traffic. Test not only for functionality but also for asynchronous behavior. This means checking how tasks run concurrently and ensuring that your app doesn't get blocked while waiting for IO bound operations. Then the last point here is use middleware. Asynchronous middleware for logging or preprocessing. Middleware is a great way to hook into the request or response lifecycle of your FastAPI app. With async programming, you can create async middleware that doesn't block your app while performing tasks like logging, monitoring, or data validation. Here's an example of async middleware. Here's an example of async middleware that logs requests without blocking the main app. This middleware non-blocking, the async middleware, the async middleware doesn't halt the request response cycle, so other requests can be handled in the meantime. Using async middleware lets you keep your app clean and non-blocking while still handling things like logging, authentication, and metrics collection. Testing is essential when developing APIs, but with async code, it comes with its own set of challenges. Fortunately, FastAPI has you covered with built-in test tools, and we are going to walk you through why testing async APIs is so important. You might be wondering, why do I need to test async endpoint? The shorter answer is to ensure that everything works under real-world conditions. Here are the main reasons to test your async endpoint. The first point is ensure correctness. Make sure the API behaves as expected when multiple requests are being processed at once. The second point is validate performance. The async behavior works as expected and doesn't cause issues under load. The third point is catch concurrency issues. Ensure that the async tasks are truly running concurrently without stepping on each other's toes. That is no race conditions.
Fast API text clients is built on top of HTTPX, which means you can easily test your async endpoint with it. The Fast API text client makes it simple to simulate requests and get responses from your app without having to run a live server. In our code sample, we create a test client instance for our app. Then we use the client to make GET requests and assert that the responses are correct. The cool part is Fast API's text client works seamlessly with async code. So you can test your async endpoints just like any other endpoint. The test client makes writing text for async code super easy because it handles the async calls behind the scenes and allows you to run tests synchronously. Covered all the important concepts. Here's a quick recap of why asynchronous programming is a game changer in FastAPI and how to make the most of it. Number one is scalability. Programming helps you handle many requests at once without blocking the main thread. This means your APIs are ready for growth and can scale efficiently under heavy loads. The second point is responsiveness. Async operations keep your APIs fast and user-friendly even when dealing with IO-bound tasks like making HTTP requests or querying databases. Your users will always get quick responses, even if the backend is busy. The third point is efficiency. By avoiding idle waits during I/O operations, async programming helps you optimize resource usage. It ensures that your app is never sitting idle, waiting for things like file reads or database queries. Then we have the best practices. Make sure you use async libraries to avoid blocking apps performance with tools like Prometheus or New Relic. Test your async endpoint thoroughly to identify any potential bottlenecks. Use async middleware for efficient request processing. With async programming in FastAPI, you're building fast, efficient, and scalable APIs that can handle massive amounts of traffic with ease. Keep these best practices in mind. Monitor your app's performance and test thoroughly to ensure everything runs like a well-oiled machine.